All right, Unit 3 review. I tried to put a few notes in the review and the directions to help you. They're not necessarily things I'm going to put on the test, quiz, quest, whatever you want to call it, itself, but kind of here to remind us of some things. So here in this first part, okay, add and subtract the polynomials. Do not multiply, because I've got some of you that are still wanting to make like a 4x3 box out of this. And the thing that's really kind of sad about that is you do all that work and the answer's not even right. So what I'm going to do is I'm going to pay close attention to what sign's in the middle. Because if it's a plus, it's really not doing anything at all as far as that goes. So for instance here, that plus, I'm going to start with my largest exponent term, and I'm just going to start combining like terms. Now when we're combining like terms, we don't mess with the exponents at all. We just use those to figure out what I can put together. And I start from the largest exponent and I work my way down. So like I don't have any x to the thirds. Then I have x squared. Let's see here, x's, I got a couple of those, but again, I got to pay attention. It's 7 minus 6 would be 1. And 2 minus 9 is negative 7. Okay? I can't keep going from here. There's nothing else that's alike that I can put together. But biggest degree down to least, I'm just combining like terms. Now letter B, though, a little bit different of a twist. Okay? That minus that's there works its way through to every term in the parentheses after. That's why they're there. I'm subtracting that entire quantity. So typically what I will do in this case is I'll go ahead and I'll write each of these terms in afterwards. So I have a negative 4x to the third. Negative times negative is a positive 7x. And then negative times positive is a negative 2. Once that's situated, now I'll go back and I'll combine the like terms. And again, just starting at the biggest degree and going down to the least. 15 minus 4 is 11, x to the third. Negative 8 plus 7 would be a negative 1x. And then negative 11 minus 2. If I owe somebody $11, I borrow 2 more. Now I owe them 13. And I'm done. But again, keep life simple. Don't try to do too much. So then when I get to number 2, it says let f of x equal 9x to the third plus 2x squared minus 4x. Find f of negative 4. Evaluate. Okay, again, this part won't be there on the actual, test, quiz, whatever we want to call it. But for now, it's helpful. Plug negative 4 in for x. Whatever number's in the parentheses, that just means I plug that in when I'm doing the x. And I always want to use parentheses, because sometimes that would cause my sign to change otherwise. So everywhere there's an x, in goes negative 4. And at that point, you can do a couple of things. You can do each part separately if you want to. Or if you wanted to, you also could just type the entire thing into your calculator. And again, if it's something bigger than squared, I just use this caret button that's above the divide. And everything else I just go ahead and get plugged in. And it's okay to get really big numbers sometimes. That'll happen. And that's my answer, and that's it. Okay? But I'm literally replacing the x with a 4. I'm not just multiplying by that and getting out some really big, funky-looking answer.
So it's that basic.
Yeah, it's that straightforward. If you plug in a number, you get a number out. That's it. No variables, no nothing. So sometimes the easiest ones can be the hardest if we kind of overthink those. Okay, 3. NHS is selling handmade scarves for a fundraiser. The revenue, R of x, from the sale of x scarves is given by R of x equals 16x, which means I'm selling them for $16 a piece. Suppose the function for the cost of manufacturing x scarves is 4.5x plus 120. In other words, it costs me $4.50 a scarf plus $120 for setup, whatever it happens to be, supplies, something like that. So when we get to that first question, what are the scarves selling for? The answer is not a fundraiser. The answer is, how much, I guess I could write it that way instead, might be a little nicer. But what are they selling for? My revenue would be $16 for each one. That's what I put. Okay. Write the profit function. Sales or revenue minus expenses. So my revenue, my sales is 16x. My expenses are 4.5x plus 120, but notice the parentheses. I'm subtracting that entire quantity, okay, not just the 4.5. So when I go to put this together, and I'm not just going to leave it this way, I'm actually going to simplify it. I'm going to distribute that negative through, give myself a little more room up here. So that negative goes to the 4.5x and the 120. Then I can combine the like terms, but not until then. Okay, so this would be my profit function, 11.5x minus 120. And that's what I'm going to use when I get to part C. So you see, these kind of go together. If I mess this up, I'm going to mess this up. Find the profit on 60 scarves. Plug 60 in for x on part B. So 11.5 times 60 minus 120. So let's get that knocked out here. Let's see what that's going to be. And this is why it's good to show work. So like let's say this is what you were doing on your quest tomorrow. And somehow you'd mess this part up. But you show me what you were doing to show me to understand this step. Even if this step was wrong and then you plugged it in and got a different answer, you might get some credit on that if you showed me what you're doing. Because I'm like, well, they did the step right. They just didn't have the right formula they were using or the right expression. So it pays to show those things to me. So then we get some more power function stuff. And you'll see why we spent some extra time on this yesterday. So we have our f of x and g of x. Write an expression for each function, state any domain restrictions. Do not multiply by x. That is a label. Okay. Sometimes on the worksheets, it's looked something like this. And that's more of the way I want you to think about it. So when I'm doing this, all I'm doing is I'm taking my f of x function, 2x minus 3, I'll use my parentheses here, plus my g of x function, x plus 1. And since there's no minus this time, there's nothing I really got to distribute. So in this case, I can just go looking for like terms. So 2x and 1x would be 3x. Don't mess with the exponents, we're just combining like terms. And then negative 3 plus 1 is negative 2, and I'm set. So not a bad deal. When I get to 5, okay, fg, same thing as doing f of x times g of x. And since they're both binomials, this is where we typically head for doing a box. Now, if you're more comfortable with FOIL, that's okay, but make sure you FOIL it out. You don't just multiply the first and last terms, because then you lose your middle term and it's not right. So when we're multiplying, when we're doing the box, we're multiplying to fill the box. So I multiply my coefficients, add my exponents, and I'm going to do that all the way around. Multiply the coefficients. No other exponents to add, it looks like here. Okay, so once my box is filled up by multiplying, now I'm just combining like terms. No more messing with exponents. And I go from the biggest exponent down to the least. But again, that x that's outside is just a label. I don't multiply through by that at the end, because that would mess me up. And then 6, there's a possible double whammy. You're like, okay, so f of x, that's 2x minus 3, g of x, x plus 1. And here's why I like the parentheses on this one, different reason. You're going to be tempted to cancel those x's out. You can't. This x is bonded with this plus 1. This is bonded with minus 3. Those bonds can only be broken if you have the identical thing come along. So like if I had another x plus 1 up here, I could cancel them. But I don't, so I can't. So that's actually as far as that one goes. But, ooh, domain restrictions. Remember, reminder, the denominator cannot equal 0. So I have to make sure that doesn't happen. So I'm going to take my denominator. I'm going to set it to not equal 0. And I'm going to solve the mini equation by minusing 1 to both sides. Okay, so I know x can't be negative 1 because that would cause 0. But for me to write my domain, I do it one of two ways. And we were talking about this yesterday as well. I can either do the double bar r, which stands for all reals, and say every real number except negative 1 is okay. I can write it that way. Or if I don't want to do that for some reason, I can just write all reals not equal to negative 1. Okay? Either one of those is okay, but I have to have it there. Because if I don't write it there, I'm assuming I can plug any number in I want for x, and that's not true in this case. So there are some little things I really do have to watch for, but the only time I got to worry about that's with fractions, with the dividing part. Otherwise, that's not a big deal. All right, more functions. P of x, 2 times the absolute value of x minus 4. Q of x is 7 minus x. So when we're going along with these, all good, thank you. Here? Yep.
Thank you.
So what we're going to do here is, again, this is like the multiply we had up in 5. So what I'm going to do is I'm going to go ahead and I'm going to do P of 3, find an answer. I'm going to do Q of 3, we'll find an answer. And then we'll multiply them together. So when I go to look here, I'm like, okay, so if I stick a 3 in here, that'd be 2, and that'd be 3 minus 4. So 3 minus 4 is negative 1, but what does absolute value do to numbers inside once they're simplified? Well, not change the sign necessarily, but it always is going to come out positive. So if it would have been positive, it'd still stay positive. So this is just going to be 2 times 1, or 2. So I got that part set. Then I move over to Q of x. 7 minus 3, which is 4, which is my other part. And then I just multiply those two guys together and I'm done. Don't overcomplicate things. This is one, again, where I have people doing odd things and trying to box and foil this out. Don't go to all that trouble. Keep it simple. However, compositions. Okay, compositions, remember, this is where I plug one into the other. So this is a two-stepper. When we've done these before, my first job is to find P of 4, what's ever on the innermost part of the parentheses here. Okay, since my P is this, P of 4 would be 2 times the absolute value of 4 minus 4. You're like, wait, that's 0. 2 times 0 is just 0. That's true. So you're like, am I done? No. I just figured out what this is. P of 4 is 0. So my last step now is to find Q of P of 4, which is 0. So I plug 0 into the second one. And whatever answer I get is my answer. So when it's composition, you're literally plugging one into the other after you've solved it. It's like doing two separate problems. That's kind of, we kind of broke it up here. But I got to go that route or it gets crazy. It's not multiplying. It's literally plugging one thing in for the other. Okay. So 9. Find the inverse. Switch x and y and solve. You're like, wait, I don't see a y anywhere. Remember, f of x is a fancy way, a function notation of saying y equals. So if I want to cross it out and write it as y equals, I can. Switch the x and y around. And now I'm going to solve for y. And we've talked a couple of different ways on how you can do this. Okay, I can multiply by the reciprocal. So I could multiply both sides by negative 3/2. So that'd wipe out the fraction on this side. Okay, and we talked about how that little negative one's like a label to say this is the inverse. If I don't have it, it's not wrong. But if you thinking in regards to reciprocals doesn't work for you, here's your other option. Once you switch them, and I'm basically going to do the same thing. I'm just going to take 2 steps to do it instead of 1. I could multiply both sides by 3, which is get rid of the fraction part. Okay, it's about finding a way that works for you, and then dividing by negative 2. Okay? Either way, because it doesn't matter if the negative's on the top or bottom as long as I have it there. They both work. Okay? So if you're more classic and you want to do one step at a time, cool. If you want to jump in both feet and do a reciprocal, that's cool. They both get me to the right spot. And then there's one more just like it. Okay? F of x, we know that's y. Find the inverse. So we switch those guys up. Little different this time though, a little bigger. What should I do first? Add 14. Bless you. Okay, so this is x plus 14. Not 14x, not multiplying. Now this one I'll admit, I'm going to go the route we did on this second one up here, just because otherwise I got to remember the distributing part, and that can get to be a little bit of a pain. So I'm going to go ahead and just multiply by 2 to get rid of the fraction here. I'm going to take one extra step, but I think it's worth it. And I'm going to distribute my 2. So 2x plus 28, because it goes to both terms. And now I can do my one last step. And this way I remember to divide everything by 7. Because otherwise it can be very easy to forget how to divide one of those. Because I'm not going to be taking from people, hi, it's 2/7 x plus 14. People forget to distribute, they'll forget to simplify. It's just easier if you do it step by step so you don't forget any of those. Okay. So then I keep bobbing along, and I'm like, all right, what else we got here? Graph 2 examples of functions whose inverses are also functions. Okay, here's the biggie here. I just need 2 things that can pass the horizontal line test, where it only goes through my graph one time when I draw a horizontal line. There's a whole bunch of options I'd have here. I could, let's see here, what are some things I can come up with? Plain old line, okay? Because here, if I do the horizontal line test, it only goes through at one point, okay? That works. I could draw, I don't know, kind of a funky hyperbola like that. Again, I go to draw a horizontal line through it. It only passes at one point. That works. You could draw like a sideways parabola, okay? Not up and down, but a sideways one would still pass. That would work. So just a couple of graphs of things that would work. Now don't draw me the same line twice. Okay, be a little creative here. And that would give me a couple of examples of functions whose inverses are functions. Oh, then our favorite. And yes, you can use the flowchart. that you got before tomorrow if you want to do that. Okay? Because when I'm looking at these, I want to dig into those to make sure, that I'm giving myself the best chance. But the biggest thing, always look first to see if something factors out. Because if it does, it'll make my life easier. So I look at 8 and 216. I'm like, you know what? These both look like even numbers. I think something's going to come out of there. So let's see here. 8 and 216. What if I just do 2? What would that do? Let's try that out first. Okay, so that would give me... So if I took out a 2, that would give me 4 and 108. Well, wait a minute. I think I can still take something out of there. Maybe I didn't take a big enough number. Okay, let's try this again. What if I do like 4? Let's try 4 with both of them here. 2 and 54. Well, wait, that's even going to work. Woo! Was 8 going to work? I know 8 goes into 8. Okay, so 8 is going to be my best option. So I'm going to scratch this one. I'm going to go to 8. 8 went in 27 times. Okay, so I get to here. Is there anything else that I can do? Is this one of those where I can only take out the 8? Well, no. Because if I start to look at those and I've got my little chart, I notice I have perfect cubes working here. There was a cube? Yeah. Because I'm waiting for I think you're leading towards the question that might get asked here.
Aren't they both perfect squares? Yeah. I mean, that's
perfect cubes. Okay, good question. What would happen if I noticed they were both perfect cubes at the start and I just started running with it then? I will come back and answer that when we get finished with it this way, and we'll see if we get the same thing at the end. So, if I'm looking at this particular way that we did it, I'd cube x to get x cubed. I'd cube 3 to get 27. So, that 8 that I took out at the beginning, I'm going to leave that out front. Okay, and remember, on your flow chart, you've got the pattern for this. And the pattern runs something like this. I write my 2 terms, steal that sign to go in the middle, so the x and the 3, I just do x plus 3. And then the rest of the pattern works like this. I square my first term, so x squared. Change the sign, so whatever was here, so it started with plus, we go to minus. Multiply my 2 terms together. 3 times x is 3x. And then square my last term. 3 squared is 9. And that's my answer. Now, let's just say you noticed at the beginning that 8 and 216 were perfect cubes. You looked at your list, you're like, hey, they're both on the list. So if I just jumped in right away, what would happen? Well, let's see. So I'd have said, okay, what do I cube to get 8? That'd be 2, so 2x. What do I cube to get 216? That's 6. So let's go ahead. All right, so it's my 2 terms with a plus in the middle. I square my first term, so I'm going to square the 2 and the x, which would be 4x squared. Change my sign. Multiply them together. And then plus my last term squared. Now, this may come as a surprise to some of you. If I were to box and FOIL both of these out, I'd get back to this on both of them. So you're like, but they look different. Here's the difference. This one, on a very small technicality, this is not something I would nail you on this quiz, even though technically I should. This one, if you notice, I've got common terms in both of them. I could take a 2 out of both of these. Okay, so if I took a 2 out of there, I could take a 4 out of all of these, and you're going to be amazed at what you see. Well, maybe not amazed. Then look what's on the outside, 2 and 4. What's 2 times 4? 8. And then if I write down the parentheses that are left over, it's the exact same thing. Okay, so that's why I always say with the golden rule, if you look to see what you can take out first, that would avoid all this extra dilemma. Like tomorrow on the class, this would probably be a 3-point question. I'm probably not even going to take a 1/2 point if you just do it this way, because I'm just going to be happy that you got through it. But if you want to get to like the answer, like the ultimate perfect answer, having that 8 out in advance would be the way to get there. But I'm glad you guys asked that, because that's a good thing to look at, because they both work, really. So nicely played. All right, challenges. 13. You're like, what? We haven't done anything with the 4th. Okay, wait. Let me ask you a different question on this one and see if this helps make a little more sense out of it. What if this were the question instead? Would that be recognizable? I hope so. It's a difference of squares. So if I was doing this one, just kind of watch on this. What do you square to get 16? 4. So I'd have 4x and 4x. What about 49? 7. And we know with difference of squares, it's plus minus. Here's the only difference. So I've got my 4. Okay. X times x is x squared. What times what is x to the 4th? Yeah. It just means instead of 4x and 4x, now it's going to be 4x squared, because 2 plus 2 gets me to 4. And now instead of it just being 49, it's 49y squared, which means I put a y on each of those. Okay? Really no different than a difference of squares. It's just making that application with my exponents. But otherwise, just a difference of squares, not a big deal. Excuse me. And then our next two are our 4-termers, and we've got on there. We pair them off. We find the greatest common factor in each pair. Sometimes that'll be a number and a variable. Sometimes it's just a variable. For this first pair, it's just x squared. Then I'm like, okay, what do I have to multiply x squared by to get each of these back? Well, I need a 2. I got 2 x's. I need to get to 3, so I need one more. And then for my second term, I need the 3. But I've already got x squared, so no more variables there. And sometimes we may even get to one of these and say, hey, I don't see anything they have in common. Well, I guess they're both negative. I could take a -1. I guess I could go that route. So a negative times what gets me to -2, that'd be positive 2. X, and -1 times what gets me to -3, positive 3. There's my goal. Those two suckers end up being the same. If that works, then I did it right. And I paired them off. And I pair the greatest common factors off. Now, I got to admit something. I'm not going to do this to you on the quiz, on the test, but I did on this one. I just noticed it. When I get to the end, I notice, I'm like, oh, crap. That's a difference of squares. I can factor that still. So if I were to get into that situation, yes, I would have to factor this again. But like I said, I'm going to be happy that you're getting to here. So, I mean, it's good to know, it's good to visualize, because as we get going in second semester, there will be some situations where this happens, and I'm going to have to be able to do it. But I didn't mean to do that on this, actually. It just kind of happened that way. So, just something to ponder. All right, so one more pair them off here. And I think I may have done it again. It's going to make me laugh. Let's see. What do those first two have in common in 15? Squared. Nice. Okay. So let's see. 5x minus 1. Because again, if you think there's nothing in common, you're usually going to have a 1 there. Then plus, like there's nothing in common. Yes, there is. There's always a 1 in common. You're like, but 1 doesn't do anything. It'd just be the same thing. Exactly. In this case, that's a good thing because my parentheses are the same now. My quantities are the same. This time, though, we don't have to factor. You're like, wait, why not? Because x squared is still a square, and so is 1. That's true, but there's no such thing on your flow chart as a sum of squares. There's a difference of squares, but there's no sum. So that's as far as I'd be able to go. So you kind of see with this, there's a whole lot of detail involved in trying to keep up with all of this stuff. Ooh, 16. Those two have anything in common? X. What about numerically? They both have 4. Okay. So let's see where that gets me. I already got the 4. X to get to x cubed, I need x squared. And what is 256 divided by 4? What a coincidence. Am I done? No. You're like, why you got to make every single one of these factorable again? Okay, because I've got a difference of squares. So I square x to get x squared. What do I square to get 64? 8. I'd cube 4. Yeah, I'd cube 4 to get 64 and a plus minus. Okay, now I'm good. I know some of you start to doubt yourselves. Like, no, you stick with your guns on that. And I'm set. So you notice the theme here. Is there anything in common? Okay, I'm like, we'll get there. 3x cubed. Okay. So 3x cubed. All right, already got the 3. X cubed to get x to the 5th. X squared. 3 to get to 24. 8x. And 3 to get to 36. 12. No more x's down there because I already got x cubed. Guess what? We're not done. It's factorable. You guys are reading my mind. All right. So reminder, we're in diamond mode here. Multiply to get 12, add to get negative 8. So let's see. I know for sure that they're both going to be negative because negative times negative is positive and add to a negative. And correct. 6 and 2 multiply to 12 and add to 8. Nice. We are done for once on this one. All right, last one, no tricks. 8 and 125 are both perfect cubes. So I cube 2 to get 8, x to get x cubed, and I cube 5 to get 125. And I can't stress the importance enough of doing it this way so you can see the parts that you're working with. Even with the flow chart, it's going to make it a lot easier. So I write my 2x and my 5 and steal the sign from the original problem. So it starts with minus. That's what I'm going to do. All right, let's see here. So, okay, here comes our pattern. Square my first term. The 2 and the x both get squared. Switch my sign. I started with minus. I go to plus. Multiply those guys together. So 2x times 5 is 10x. And then plus my last term squared. 5 squared is 25. Whew. Never thought we were going to get out of that factoring section. Holy crap. All right. We're nearing the end. We have made it to the last page. All right, divide. Now, you have a choice. Notice I didn't tell you which way, so you can do synthetic, you can do long. I'm assuming most of you are probably going to want to go synthetic. So remember on this one, since they're giving me a binomial, I got to figure out the x value, which will be the opposite here. So I'm going to use 3, not -3 in my little box. Now, remember, we start from the highest degree and work our way down. So am I just going to write 2, -4, 5? No. What's missing? I need a 0 where the x squared should be, because I can only go down one step at a time. 3, 2, 1, 0. So if I'm missing a step, I have to put a 0 in to hold the place. So I'm going to go ahead, pull that first term down. 2 times 3 is 6. Add down. 6 times 3 is 18. Add down. 14 times 3 is 42. Add down. Okay, I don't get just to leave numbers though. To put my variables back in, 1 degree lower than what you started with. So I started with x to the third, so I'm going to go x squared, x. There's my constant term, and if I have a number left here, that's my remainder. And whatever that binomial was I was dividing by is what I'm going to put there. And I'm set with that. So one more with the synthetic, and then I'm going to bounce around slightly. I'm going to go down to 22, 23, and pop back up to 21 to end here. What's going to go in my little box for 20? 4. Do we have any holes this time?
No.
Oh, look again.
Oh, yes.
Yeah. Third, second, I need one for plain old x.
I thought that would be 2.
Nope, because the 2 doesn't have a variable. So 3, 2, 1, 0 with my 2. And we just run the same process we did in 19. Multiply and add. Multiply and add. Multiply. Ooh, that's a big one. And add. And just like we had on number 19, started with an x to the third up my original. Start one below that. So 2, 1, 0. Remainder. Nothing too terribly awful again. Now, I will come back to long in just a second. You're like, we're on a division roll. Why are you stopping? Because I want to make sure of a couple of things down here at the bottom.
Okay, we use the box for that.
Down here, yes, because remember, x minus 4 to the third means we have 3 of these. Okay, you cannot just cube x and 4 and be done. I wish it were that easy. I really do, but it's not. And for time's sake, I'm going to help on this first box. I'd box those first 2. And that's what I would end up with on those first 2 when I worked them out. But notice I still have 1 left I haven't used. So what I'm going to do at that point is I'm going to use that last one to do a bigger box. And this, when I get done with this one, will actually give me my answer. So again, we're multiplying to fill, which is adding our exponents. X times x is x squared. 16 times x is 16x. Negative 4x squared. Little details. Negative times negative is positive. Negative times positive is negative. But the nice thing again with the box, all my like terms are grouped for me. start for the biggest degree. -4 and -8. We're just combining like terms now. No more messing with exponents once that box is full. 32 and 16 is 48x minus 64. And the nice thing about having just done number 22 is it sets our brains up to do 23. Because 23, I'm basically doing the exact same thing. I just don't have to do the first step. I'm basically just going to bust out with a big old 2x3 box here. And I'm going to do that same thing I did in 22 one more time. So let's see here. Add my exponents. 2 times -2 is -4. Add my exponents. 2 times 4 is 8. 3 times 3 is 9. 3 times -2 is -6. And 3 times 4 is 12. And then again, I just go into combine like term mode. So 9 minus 4, I still have to pay attention to signs though. 8 minus 6. And I'm set with that. So you kind of start to see some of these same patterns come back over and over. But again, it's just about taking your time and being detail oriented. Okay, last one. Got to rewind here to 21. Okay, long division. Okay. These are the ones where we talked about doing some side work. No holes, that's nice. All right. So just a reminder on this, my side work is always going to be 2 steps to it. It's always my first term under the division sign divided by my first term on the outside. 6 divided by 2 is 3, and subtract your exponents when you're dividing. 3 minus 1 is x squared, so that goes up here. And then my second step before I repeat the process is to take that first answer, 3x squared, and multiply it by my divisor, the 2x minus 1. So I do some distributing. And whatever answer I get once I distribute goes underneath. And we subtract it. That's the one I got to remember here, because it's different from synthetic. Because synthetic, we're adding. Long division, we subtract. 7 minus -3, minus a negative makes it plus. So 7 plus 3 is 10x squared. And I start the process over again. So you're like, okay. 10x squared. Always dividing by 2x, always dividing by that first term. And then 2 minus 1 is 1, or just x. And again, it's tedious. I'm not going to tell you it's not. It is. But sometimes it's just a way we got to do to survive this. And I'm going to distribute that through. And if I'm doing it right, my first terms should always cancel each other. If they don't, something went haywire. I got to go back and look again for a minute. But this time it worked out for me. 10x squared minus 10x squared, gone. Negative x, again, minus a negative makes this plus. -1 plus 5 is positive 4x. We've got to do it one last time. Like, how do I know again when I get to stop? Because when I get to a point that I can't divide these anymore, that's when I get to stop. But I can do 4x divided by 2x. I get 2. Then 2 times 2x minus 1. Oh. If I'd had any more to do, I'd have had no room. And lucky me, when I subtract, nothing's left. There is no remainder. I am done. Okay. Now again, as you can see through this, there's a lot of things to consider, but it's good to go back through. If, as you were doing something, you're like, oh, I get that now, go back, do that homework, or do a couple of problems from it just to reinforce it, and then you'll be ready to just whoop this down tomorrow. Okay? But if there's any more issues, again, double check this. Pop in a couple minutes early. Excuse me tomorrow, ask a question.